Hey everybody, this is Larry. This is day 7 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's file. I don't know I'm still working out a workflow for this. Don't know which page to kind of start because I like before it had this explore page and it was very obvious what time it is and stuff like that. But now everything's a little bit awkward. So bear with me as I'm trying to figure these things out myself. But today it's going to be day 7. I'm looking on the right side and let's take a look. And it seems like today's problem is word search from the URL. We did do a word search problem recently, maybe 2 weeks ago on the Leetcode contest, but maybe I'm wrong on that one. I don't remember. But anyway, so let's take a look. So yeah, one thing I would say is that we usually solve these live because that's the point. So if it's a little bit slow, yeah, or whatever, let me know, and then I will ignore you because you have the power to fast forward. I wouldn't say as fast as I can. I'm going at the pace that I'm gonna go at. So yeah. Anyway, so today's problem is word search number 79. Okay, given an n by n grid, return true if the word exists. Okay, so horizontally and vertically, okay, it doesn't have to go backwards unlike the other one. Oh wait, Oh, it's a word search, not a crossword. Okay, we had something similar. Yeah, I mean, well, the follow-up kind of gives away the game a little bit, which is, I don't think there's an easy way to do it other than to do a pruning type thing. There are kind of some nuance to that because depending on the input, it may be way tricky. You can definitely construct some exponential type things. That said, word length is only 15, so in theory, I guess in the worst case, it'll be like 3 to the 15 or something like that. Not 4 to the 15 because you don't go back to the direction you come from, and of course it's actually even strictly speaking less than 3 to the 15 because you can there are a lot of self-constraining things like you can go loop around and stuff like that. M times n is 36, which means that it's probably gonna be small enough for us to do this. Yeah, I mean I think these things in general, right, not just for this problem, I think knowing the literature around these things will help you kind of not try to make a fool of yourself by either try to be like, oh yeah, no, I can do this in linear time, when if you know the literature, you can construct cases that you can't. So what that means is that even though your worst case complexity might not improve per se, for these kind of problems, for these kind of problems where you know it's going to be exponential, then you have a couple of choices, right? You can kind of what do the follow-up suggests, which is have some kind of branch and bound. So you have to kind of figure out what to bound. You can have some kind of A star E algorithm to maybe even help you search a little bit with some heuristic around the I forget what the name of the function is, but just like the cost function effectively, or distance function, I forget what they call it in A star, but that kind of function. So that's one way to do it. Another way of doing it is, of course, just knowing that maybe it doesn't apply for this particular case, but for these kind of problems, or especially for optimization E problems, maybe it's okay to not necessarily have the absolute best answer, but to have an answer that is within, say, X% of the best answer, right? And then you do proofs on that, on how that is true. For example, the most famous one, well, it's most textbook one anyway for me, is like the minimum spanning. I combine those words in the Manning, but minimum spanning tree approximation of the traveling salesperson problem, right? For example, then you get the 1.5x or so, using triangle inequality and stuff like that. You can on a planar graph. There's stuff like that you can do, right? So yeah, okay. So I kind of talked a bit, but I think the TLDR is that in these kind of problems in real life, and actually these kind of problems probably more happen in real life, knowing the literature will allow you to kind of stop searching for stop searching for a solution that's not possible, because that's just how our certain classes of problems go, right? Anyway, okay, now let's get actually started. So now we know it's going to be brute force. Let's do the brute force. And then if so, these things, my suggestion, and it depends on the constraints and stuff like that, and your confidence and stuff like that. But the first thing I would do is just get a working solution. It might not be that fast. It may be too slow even, but that should be good. At least get something that's working. Two is that for this particular one, it's a little bit iffy, especially for online judges and for competitive, which is why you don't really see these things in competitive, but you do see these kind of problems in real life, is because it's okay. You only need it to work for certain inputs, right? Excuse me. Yes. But yeah, in real life, you only really need it to work for certain inputs, and you don't have to have things work for every type of input, right? Where in these things, in theory, these are the only constraints, and therefore you can have a lot of crazier inputs. For example, maybe in your real test case, the distribution of letters are like English distribution of letters. In that case, like maybe certain letters come up more often and certain letters are not, and therefore if you do certain pruning, it may be better or something like that, right? I'm just giving an example of something that can happen in real life and actually do. So therefore your pruning would have to depend on the input set, and that's okay. But here and in competitive and so forth, you have to be more prepared for every type of whatever, because people can challenge it, so it's a little bit awkward. But anyway, okay, so I've kind of talked about a lot of context behind these kind of problems. Hopefully it is interesting or useful or not, I don't know. But let's get started about let's get started on this problem, right? We just kind of go, okay, so the same letter cell cannot be used more than once. I think that maybe, at least in this case, it should be okay. So then now what are our recursive states, right? Our recursive states, I'm just going to go because naming thing is hard, which is, let's just say x, y, and then index of the word, and then maybe a sort of a, we won't put it into the parameters, but a scene lookup, so that we don't visit the same cell twice, right? So let's do all is, I know I don't like using m and n for grids, so I do it this way. Oops, that would fail actually. But let's see, making sure that this has to be at least 0, because sometimes it's a very weird one, but they do full one add use sometimes. Okay, so yeah, so here, so that's our definition. So then now we can just start at every cell, right? So let's kick it off. So let's just do for x in range of R, for y in range of C, if go of x, y, and 0, then return true, I guess. Otherwise, return false. So this is just starting us off. I don't know if this is going to be fast enough, but that's okay. We know that there isn't like a good optimal or like a sub-exponential optimal solution. So, it's just about feeling things out. So, yeah, maybe there's some optimizations that we can do, but I would like to keep it simple, keep it stupid, and keep it going. Okay, but yeah, okay. So in this case, we go, okay, if board of xy is equal to words of I, or if this is not, we return false. Oops. Otherwise, we want to mark xy is true. We do some recursion and then we mark it as false, right? So yeah, and in this case we will return false as the default case. That means that the rest of it fail. And then here we have to do up, down, left, right. So let's do that. So direction is equal to, and we can even actually add this as well. So if seen and y or this, that means that we already saw it, then we return false because we shouldn't be going that way. Okay. Also remember that most of my commentary is, or all of it is off the cuff. So that means that I do not know the problem coming up. And so some of the commentary is a little bit, maybe it could be more structured, not gonna lie. But you know, these are the things that I just know off my head, right? So yeah. Okay, so here we go. Okay, so we just have to do, oops, for dxdy and directions. Yeah, I guess we can, if go x plus dx, y plus dy, I plus 1, we return true. We actually have to do a few other things, of course. Actually, so if I is equal to length of word, which we'll say is n, then we return true, because that means that we've done every part of the word. And then the other thing I want to do is also bound checking. So, and this is actually after this. Easy mistake to make actually, but the other one will do. So if and I know that we could do the whatchamacallit, modus polling, but I'm not going to. So yeah, so if this is not the case, we return false. And here I believe we are good enough to give it a spin. Ooh, Did I mix it up? Okay. Okay, so I think the reason why I kind of moved this back and forth is because, so if we can see it, then this is false, but then if I goes to back, and then if this thing is returned false, that's why. But I was a little bit lazy to kind of think it through. I just didn't think it through, to be honest. I was a little bit lazy, but yeah, now that I see it, this makes sense, and it looks good for the input. So let's give it a submit. I don't know if it's gonna be fast enough, because these things, you just have to be fast enough. So we'll let it go. And as you can see, and which I always complain that I don't like, is that you can see previous things. Oh no. I wonder if I made the same mistake here, but let's see. Oh, I see why. So this is true, but then we never, because this thing now, it always has to go out of bounds, right? To go thing. I wonder what mistake did I make. I mean, I will fix this, but I'm just curious what I did last time. I hope it's not the same one. Okay, well, it is the same one, and I guess it's consistent, and I did something similar, actually. But, okay. Well, I mean, you can't say I'm not consistent. A year and a half later, I make the same mistake. But, okay. I should have tested this, though. But, okay. How do I want to fix this? I mean, so there are only two ways to fix this, which is one is changing the precondition, or the other one's changing the base case. Actually, yeah. I think actually, now that I think about it a little bit, if I is equal to, no, because we can't go backwards or out of bounds. No, I think this is okay. Maybe I misspoke here. Why are these uppercases and these are lower cases? Maybe that is a better base case. I didn't really think it through. It's just that if you're already at I is equal to n, it doesn't matter what anything else is, because you don't need this letter. So none of these things matter, even if it's out of bounds. But it is an awkward. It definitely is an awkward base case to kind of say out loud, though. That's why it's a little bit weird. Watch I get another wrong answer, then I did worse than last time. Now, okay. Though, oh, look, the streak is actually good. And, oh, now I know my actual streak. Okay, good. Thanks, Leetcode, for finally fixing that. Okay. I mean, so yeah, so like I said before, now we can think about it a little bit. So I know I have some idea on how to fix this a little bit. In terms, because basically what I did was that I was lazy and I make these function calls, and these function calls, especially in Python, is very slow. So what I should have done is have if statements before the function call, so that it gets cheaper, because we're doing millions and millions of these. So that's probably a easy fix. So I'm not really, and actually, what the wow, this is still better than 75%, which is kind of awkward. But I'm not going to do that here, but yeah, but these are the things that you can do. And here's all the code in case you want to see it. But, yeah, I mean, we can look at my, like I said, I don't like seeing my previous results before this, because I don't remember it. And because if I did, and if I cheated or something, I would have not made the same mistake twice. So, but yeah, I think I just did the same thing, but I put stuff a little bit before. Yeah, so that's the thing, right? Is that just putting this statement in before this statement makes that much difference, which is kind of weird, right? But that's it. I understand why, because of the function call and the function overhead and stuff like that. It's actually not cheap, especially in Python, but also especially if you do it millions and millions of times, which they probably have been inputs for it. But yeah, that's all I have for this one. Let me know what you think. Hit the like button, hit the subscribe button, join me in Discord. Have a great rest of the week. Yeah, I'll see you later. Stay good, stay healthy, to good mental health. Bye bye.